would like to talk about percent yield today. For a percent yield calculation, the percent yield calculations, first of all, are the same for general chemistry as organic. They don't change. Okay. But a percent yield is going to be your actual yield, what you actually isolate in lab, divided by a theoretical yield, or the theoretical yield for the reaction, times 100. That will give you your percent yield for that reaction. Okay. The actual yield, easiest to find because you actually weigh that out in lab. Okay. Now, the theoretical yield is a little more difficult. Let's talk about how we find our theoretical yield. The first thing you need to do is start with a balanced chemical equation. We're going to make a problem up. We're going to go through a combustion reaction with propane. We have our propane, which is a gas. We're going to combine that with some oxygen, which is needed for a combustion reaction. That will produce CO2 and water. At the temperature of that reaction, the water will be a gas. We have to balance our chemical equation. For this particular equation, it requires 5 oxygens to react with our propane to give us 3 CO2s and 4 waters. Okay? Now, the problem. Here's our chemical reaction, balanced. The problem is we have 25 grams of propane gas. We have 50 grams of oxygen. We want to know how many grams of water is going to be produced from this reaction. That's going to be our theoretical yield. When we did this in lab, we actually isolated 17.5 grams. So this is our actual. Our actual yield in lab was 17.5 grams when we did this combustion reaction. We collected the water from it. We actually isolated 17.5 grams of water. We have to know a percent yield for what we isolated. We're starting with 25 grams of propane, 50 grams of oxygen. We need to know which of these is our limiting reactant. Okay. To find our limiting reactant, we first need to know how many moles of each of these reactants we have. That's a gram to mole conversion. We calculate the molar mass for our propane, which I did earlier, and it's 44. So this is the molar mass of the propane. There's 44 grams and 1 mole of propane. Okay. When we do this math, we get 0.57 moles of propane. I'm just using a capital P just to denote, keep my reactants separate. So I know a capital P stands for propane for me. Okay. Now we need to know how many moles of oxygen we have with our 50 grams. Oxygen, 32 grams per mole, because oxygen is a diatomic molecule, O2. And we get 1.6 moles of oxygen. Okay? At this point, we have the molar amount of both of our reagents that we're using in this reaction. Now we need to know which one's limiting. To do that, we're going to pick one. Doesn't matter which one, we're just going to pick one. Let's just pick the propane. Okay, it doesn't matter which reagent you pick, you just have to pick one and start from there. Okay, we're starting with 0.57 moles of propane. Now we have to look at our stoichiometry. For every 1 mole of propane, from our balanced equation, it requires 5 moles of oxygen. When we do this math, we're calculating how many moles of oxygen is required to consume or use up that molar amount of propane that we have. Okay. This requires 2.85 moles of oxygen. How many moles do we have? We have a less amount here, which is what we have in the reaction, than what is needed to react with all of that propane. So that tells us all of the propane's not going to be reacted, it's in excess, and the oxygen is actually limiting the reaction because when it's used up, the reaction stops. So the oxygen is limiting the reaction. Okay? That's our limiting reagent, or our limiting reactant. Now we start with our limiting reactant. And we use the stoichiometry in our balanced equation again. We have 5 moles of oxygen required to make 4 moles of water. Let's go ahead and extend out. This is a scientific line. For those of you not used to writing these out, we're going to go ahead and extend this out. Now we have our molar amount. We have a molar amount of water produced from this much oxygen, which is our limiting reactant. Now we need to convert the moles to grams because we actually isolated 17.5 grams of water in our reaction. Well, water has a molar mass of 18 grams per mole. So when we do this math, multiply on the top, divide by what's on the bottom, we actually get our theoretical yield. Theoretical yield. In theory, when this reaction goes 100%, we start with our limiting reactant. We calculate how many grams of product can be produced. This is, if this goes 100%, you can isolate 23.04 grams of water. We have 17.5. So now we go back to calculate our percent yield. Our actual yield of water divided by our theoretical yield of water times 100 gives us a percent yield, which is 76%. Okay. Now let's apply this to an organic problem.